So here I am using the unsupervised machine learning model to classify the three species of the flower and obtain the optimum number of clusters that will be formed. I'll be using the famous iris dataset, and I'll be using the algorithm of k-means clustering. So what does k-means clustering means? It is basically a very simple and easy way to group and classify the unlabeled data set points into so coherent subsets that we call as clusters. The idea is to find the k centers that are called as cluster centroids, that is one for each cluster, hence it means k-means clustering. It has the aim to divide n observations into k clusters in which each observations belong to the cluster with the nearest mean serving as a prototype of the cluster. And suppose the main idea, and suppose we have 100 observations and of students who have appeared for a test and they have secured some marks. So I have two columns of 100 observations, two columns name as the roll number, and the second one will be the marks that they have obtained. So I have 100 observations, and how many clusters that I can divide the 100 observations mainly into two clusters, because we only have two columns. So max to max we can divide it into two clusters. So first of all, what are the steps that can be involved in k-means clustering? Select the random k to determine the clusters which need to be formed. So for very foremost step is to determine how many clusters we need to form, and it has some methods that we are going to use further, and that will help us to determine the clusters that can be formed. Now second thing is to select the random k points or centroids. Now we have to select random points or centroids. So in our example of students information of marks and roll number, in this we have what we have to do. We have to select a random point from the roll number column and a random point from the marks column, and we will say it as centroids. We don't know, but we will say it as centroids. And now for that points, we will try to find out the difference of each dataset points with the centroids that we have assumed. And after finding out the distance, what formula we are using? We are using the Euclidean distance to find out the distance between the dataset point, each 100 dataset point, and the centroid that we have assumed. Now, after finding out the distance of each 100 dataset points from the two clusters or from two random points that we have selected, we will divide them. Now, the distance which will be the closest to any one of the cluster, we will assign the dataset point to that cluster. Okay, and we will after classifying each dataset points, we will calculate the random, and we will calculate the centroid of each cluster again that we have chosen. We will, how do we calculate the centroid? We will sum up the whole thing and we will divide it by the two, and we will calculate the centroid. And now what we gonna do? We will again do the same thing. We will again find out the Euclideans between the distance between each dataset points with the new centroid points that we have assigned. And again, if there is any such difference that in cluster 1 the distance is larger, and after iterating it is coming much closer to cluster 2, we will assign the dataset point to cluster 2, and we will do it again and again, iterate it again and again, until and unless we can say that there is not any shift of each shift of dataset point from one cluster to another. We can say that our clustering is over. Okay, now I will be importing libraries: pandas, spd, numpy, np, matplotlib, seaborn as sns clusters. Now I will be looking at the information it has ID int 64, all these things sepal length. This is a species which is a dependent variable. These are all the independent variables. So now what I will be doing, I will be containing each species into an object of Iris setosa named Virginica. And if I just look at the count of them, I just say that each species has been 50 data set points, 50 points each species contains. So total the shape is 150 rows and 6 columns. Okay, now I will look at the describe feature. This is the describe. Now look at the scatter plot. So this is the scatter plot which can give us an overview of each numerical variable. So it is basically a square plot, square matrix that give us overview of all the information. So from this ID and the ID, we just why this is same, because we have equal number of count on each of the species. In this ID and the sepal length centimeter, the blue color represents Setosa, orange represents versicolor, green represents Virginica. So what we can understand from this graph is that Setosa has small sepal length as compared to versicolor, and versicolor as small as compared to Virginica. This can be said by the said for the sepal length. Now this all the information that we can gain here. Now I will be moving on for the topic, how do we know that what value we will choose for k. So we don't know by looking at this data set how, if this data set is small, but suppose if the data set is larger, containing 10,000 rows or 15,000 rows, then it will be become difficult for us to choosing the k value. So there are some different ways to find out the optimal number of clusters, but here we are discussing the appropriate method to find the number of clusters or value of k. So what I am using an ALGO method. ALGO method, how does it work? Let me tell you this. It uses a concept of within cluster sum of squares. It is used to find out the differences between the sum of squares between each of the dataset points, and at the point from which there is not any significant change in the data and change in the distance, this will be the breakdown point, and this will be the point that we have to choose for cluster. So looking at the code, in this code I have initialized a empty list, and I am choosing a range of 1 to 11. But what is the reason for choosing range 1 to 11? Because max to max, there are 150 rows. The max value for the clusters that we can assign will be ranging from 1 to 11. Max to max, there can be how many clusters there can be. There can be 1 to 11 in this range, because the data we are dealing with is small. So for that assumption, making that assumption, I'm just going for the range 1 to 11. K means n clusters I, applying k means dot fit and appending it to the list. Now here plotting the graph. So WC, this is the cluster sum of square for all of the data set points present in the table, and after that we are seeing that it is decreasing till when the cluster becomes 2, and after when the cluster becomes 3, there seems to be a linear seems to likely to be a linear approach. So what the clusters we can assume from the graph is that the value of k will be 3. Now applying it and calling the k-means algorithm. K-means is equal to k-means and clusters 3 in it equal to k-means, calling fit predict here, and y mean 0 1 0 0 1 0 1 1. Plotting the centroids again with the red color, green color for the Virginica, orange color for the versicolor, and purple for the setosa. We can see that the cluster formation has been completed, and the final clusters after iterating over approx 300 times iterating, we found out that there is not any change on the or there is not any shifting of clusters from one to another. From here, now I will be looking at the 3D plot of the same scatter plot as 100. C color we have chosen purple for setosa, orange for versicolor, and green for virginica. I have plotted also the centroid points for the respective species. That here this will be for the setosa and this will be for virginica. This is orange is for virginica, versicolor, and green is for virginica. Yes. So thank you for this.